So I'm going to present our book chapter toward anomaly detection using explainable AIs. So this joint work with my colleagues Vinh, Wissam, Anna, and Edgardo. So this outlines of my presentation. So I will start with an overview of our AI-based security application. Then I briefly discuss the state of the art of explainable AIs or XAI and adversarial attack. Then I will introduce our Montimage AI platform, focusing on the use case for anomaly detection. And then I will show you our video demo of our platform. And then I will conclude my presentation by discussing some future work. Yeah, encryption is changing the attack landscape as of 2022, according to the survey of Zscaler. 95% of the all internet traffic is encrypted, and over 55% of attacks occur within the encrypted traffic. So encryption increase user privacy, but at the same time, it also increase the complexity of the security tool for network traffic and analysis and classification. So we are seeing a massive increase of data from IoTs and mobile devices. And with so much data and new threats coming from the environments, so we need an advanced machine learning techniques to actually to deal with floods of data and detect hidden anomalies. So at Montimage, actually, we have developed 3 AI-based security applications correspond to 3 main steps of intrusion detection and response. So while the traffic classification actually it classifies the network traffic based on the user activity, like the web traffic, web browsing, chatting, or video streaming. The anomaly detection application it distinguishes malicious traffic and normal traffic to detect potential threat. And finally, the root cause analysis. Actually, it identifies the root cause of problem to suggest appropriate solution. We aim to improve our security application to become more responsible. So when we talk about responsible AI, it's not just about achieving high accuracy, but at the same time, we aim to take into account other characteristics such as accountability, transparency, or resilience. Yeah, so this slide, I briefly discussed about the state of the art of explainable AI. So what is XAI? So XAI refer to methods and techniques that provide insight into how AI model make decisions. So for example, for the complex AI model like deep neural network with so many layers, so many higher hyper parameters, so we consider it as a black box, as it's difficult to understand these outcomes. And XAI enable user or developer to trust and effectively manage AI outcomes. So the figure on the right actually show different type of XAI. So basically, XAI can explain a particular features or all the features of the models. It can be a model specific or model agnostic. So meaning that it can be applied to any machine learning model. So regarding the format, output format, actually, XAI can provide explanation in form of arguments, model, text, or using the visualization techniques. And XAI can also provide the intrinsic explanation or some popular method like SAP and Live can provide post hoc insight of the model. Clearly that model are vulnerable to different kind of adversarial attacks. So in this case, attacker aim to manipulate input data to deceive AI models often resulting in incorrect prediction or classification. You can see on the top the very famous example. So by adding some noise, so a panda gets misclassified as a gibbon with 99% of confidence. And for the adversarial attack, we can classify it in 4 categories. So gradient-based, transfer-based, score-based, and decision-based. So while the transfer-based, so we don't need any information about the model, but we rely on the training data set. The other 3 attacks need information about the model, such as model probabilities or a prediction class. And also we can evaluate the adversarial attack in 2 different settings. So like in the untargeted setting, the attacker can flip the original label to any labels. And in the targeted setting, so the attacker flip the original label to a specific target class. In this slide, I will explore the relationship between the SAI and adversarial attack and understanding their impact on the model performance. So on one hand, SAI can provide explanation of the model outcome, and it helps to improve the model performance. And also it can be useful to produce the explanation of an adversarial attack. So in this case, we can use the SAI to prevent or detect the adversarial attack, for example, based on the sub signatures or based on whether a list of important features has been changed. And on the other hand, uh, attacker can also apply the SAI method to actually to gain the insight of the models and then direct input to trick the SAI method to produce incorrect or innocuous explanation. So in this case, we need to consider the trade-off, try to balance between the explainabilities and the resilience. So how can we do that? So basically, we can consider the different accountabilities or resilient metric. Yeah. So actually, I will introduce a Montimage AI platform to put everything together. So our platform is open source, so it offers the user an intuitive and user-friendly interface to interact with the different AI services. And we adopt popular AI method like Shark and Live actually to produce the explanation of our models. And we ensure the accountability through some quantifiable metric. And as you can see in the tables, the main difference between our platform and existing explainable platform is that actually we also exhibit resilient in detecting and mitigating attack, and we also provide different resilient metric to evaluate the resilience of our models. So this figure show an overview of our platform architecture. So on the server side, so it follows the standard AI pipeline. So it will collect the raw network traffic data from different testbed and also from the attack database using the cyber threat intelligence. And then we use our monitoring tool to to process and analyze the raw traffic to extract the features. And then we have the network traffic analysis modules actually to classify the network traffic based on the user activities or to detect, to check whether network traffic is benign or malicious. And we also introduce the SAI for resiliency analysis module. So this one we aim to apply different SAI method to detect the potential threat in our models. So the servers is written in Node.js, and it employs our monitoring tool MMT-Prof, written in C for feature extraction. And then it's also leverage popular Python libraries for deep learning and XAI. So the server side is built in React. So actually, it offers the user a way to interact with our AI services through a dashboard. So this table shows some important APIs of our components. So in this case, we support more than 70 RESTful APIs. So you can see more detail in this link. So now we will focus on the application for anomaly detection and for the user activity classification. So maybe you can have more detail in our book chapter. So yeah, actually, the IoTs or the mobile phone or devices are vulnerable to different cyber attacks. So for example, botnets, ransomware, DDoS, and also infiltration of the network from inside. So in this case, to build our detection model, so we employ the two popular deep learning techniques, stack autoencoders and convolutional neural network. So in this case, we take the raw network traffic and we have a 59 flow-based feature, and then we change the X autoencoder separately using the normal traffic and the malicious traffic, and then the output of this process will be encoded in one dimensional vector and fed it into the CNNs, and then we can classify whether the network traffic is benign or malicious. So to train our model, so we use the public dataset and also private dataset using the data collected from our honeypot. So you can see in this table, so we considered three different kind of the attack, and our model performed quite well. So the accuracy is very good. So yeah, so because we use so many features to change our model, so in this case we need to understand which feature is most important. So we apply the SAP, which is one of the most popular SAI method, and this figure shows the SAP summary plot. So in the top 10 most important features of our model for each use case. So we can see the most important feature is the flow duration. And interestingly, this feature is one of the most applied feature in the literature, actually, to detect the botnet. And another feature important findable the number of packets with a specific flag like reset, finish, or synchronization, and also the average of the total length of IP header. So by using the XAI to provide explanation of the model outcomes, we conclude that our model prediction have parities with the domain knowledge. And next, to understand the resilience of our model. So in this case, we consider a threat models of the black box attacker. So in this case, we assume that the attacker can have access to our training data set to perform different poisoning attack at varying poisoning rate of 0%, which is the baseline, 10%, 20%, and so on. So in this case, attacker can randomly choose two samples in the training dataset and swap their label, or it can flip the label of some sample from one class to a specific target class. And attacker can also generate and produce fake data that looks very similar to the real one. And then we retrain the models using the Poisson training dataset and evaluate the model, compare it with the baseline using the performance matrix and also the accuracy decrease matrix. Yeah, so this slide shows the result on the right. You can see that clearly we see that by increasing the poisoning rate, so we decrease the model accuracy. But interestingly, the model still achieve a pretty good accuracy, like 95% for infiltration detection, even under a high volume of 40% of poisoning data. But when the poisoning rate is more than 50%, so actually the model become useless because all the testing sample are classified as malicious. So we conclude that among the three attacks, so actually the model is more vulnerable against the random swapping attack and the targeted poisoning attack. Yeah. So in this slide, we saw the sub important feature before and after the attack. So in this case, we clearly see the difference between the list of most important features using the sub analysis. For example, the most important feature, flow duration, is no longer the most important one in this case. And also we cannot see any feature related to the number of TCP packet with a specific flag like finish or reset. Yeah. So by applying the XAI method, we can have another way to actually to detect potential attacks happening in our training process, for example. So I mean the sub feature is quite useful in this case. So now I will show a demo about our platform for network traffic analysis and classification. So we focus on two AI-based applications for anomaly detection and user activity classification. And we aim to showcase some important features like to build the model, to make prediction, to perform the XAI analysis or the resilient analysis, and also to measure the accountability and resilient metric. So yeah, so I will play some.
Yes. To our Montimage AI platform demo.
So can you hear the voice?
Yes. Could you please stop it? Because I think we are running out of time. We don't have wait for the demo. I'm sorry.
Okay, no problem. Yeah.
Finish the last part, like having questions for the audience. We have time for one question, for example.
To our
yeah, yeah. Yeah, so actually this last slide, so we developed a platform for network traffic analysis and classification, and also in the future we aim to consider more complex and realistic attack and try to apply some defense mechanism to have our model more resilient and also to explore our framework through more real data set. Yeah, so thank you for your listening.
Okay, thank you. Thank you. So any question from the audience about this chapter? So otherwise I have question on my side. I mean, you mentioned that you deal with encrypted traffic, right? So that probably knowledge what inside of the encrypted packets, right? How precise is your detection mechanism that is encrypted traffic?
So can you repeat the last part?
So I imagine that you have encrypted traffic, and some of the packets in this encrypted traffic are related to some specific attacks, right?
Yeah.
So, and I think it should be difficult to kind of to be really sure that this is attack, not attack, since traffic is encrypted. So, and you use specific AI methods to detect this kind of attacks within the encrypted traffic. So, how precise is your method?
Yeah, actually, we employ around 60 flow-based features to train our model, but actually, the feature we use is not. I mean, it's independently to the encrypted or the encrypted traffic or not, or the normal traffic.
Yes. Okay. So okay.
Yeah.
So do you have any specific ideas about how good your model to detect attacks within encrypted traffic?
Yeah, actually, it depends on this kind of attack. So currently, we only deal with some attack from the public data set, like the botnets or the DDoS attack. And in the future, I think that we aim to consider the data set that we collect from our honeypot, because from our honeypot we collect more and more traffic, and it can we can deal with more various attack, not only the attacks in the existing public data set. Yeah, so it's one way, one reason that we aim to improve our current framework in the near future.